Okay, angles of elevation and depression. 7.5 notes. Made sure you have that there because I did have to change it. Before we get started, I'm going to flip over to the back. Can everybody flip over to the back side with me really quick? And we are going to draw two different scenarios. One, what does a picture of angle elevation looks like, and what a picture of angle of depression looks like. Okay, angle of elevation. Angle of elevation. All right, first off, recognizing whenever you're dealing with the angle of elevation or angle of depression, it's always from the horizontal line of sight. So let's say you are standing down at ground level and a friend is standing on top of a building. Okay, here is your horizontal line of sight. Do you see horizontal means straight across, not vertically up and down, straight across, and it has to be parallel with the ground. Okay, your horizontal line of sight is parallel with the ground, which means it's going to be perpendicular with the building. Okay, you then elevate means to look up or to look down. Up. So you have your horizontal line of sight directly out to the building in front of you. You then look up to see your friend. This here is the angle of elevation. Angle of elevation is what degree measure is here from your horizontal line of sight to how far you had to look up to see your friend. Okay, now typically when we're dealing with the angle of elevation, it's always going to be from the ground. Okay, so remember that. Angle of elevation typically for us in this class is going to be where? From the ground. So this would be ground level for us. Can you see that there is a right triangle right there? Yes? All right, we're going to redraw this picture. This one we're going to title, make sure. Okay, to depress means to push down, depression. So would you be going up or going down? Down. Okay, so now you're up at the top and your friend is at the bottom. Remember, it's from the horizontal line of sight. So here's your horizontal line of sight. And remember, your horizontal line of sight is always parallel with the ground, which will be perpendicular with the building. Okay. You are looking straight out, and then you look downward to see your friend. Do you see that? Okay, now what you have to be careful with, one, you could draw your triangle one of two ways. You could draw it this way, and do you have an upside down triangle from this one over here? Yes. Typically, we don't draw our triangle that way when we're dealing with our word problems. Our triangle is still this way. And so we have our right triangle here. What you have to recognize is that the angle of depression is on the outside of your right triangle. Angle of depression. Angle of elevation is always at ground level at the bottom. Angle of depression is always at the top of your right triangle on the outside. So we will find ways to either bring it inside, either at the top or the bottom. We'll talk about that as we do some examples. What did I say earlier? That this is always parallel with the ground or this person's line of sight. Do you see that? line of sight, horizontal line of sight is you looking out horizontally. You're not looking up, you're not looking down, you're looking straight horizontal from your eyes. This is horizontal line of sight. This is horizontal line of sight. What letter do I have here? Z. And these are parallel, so what do we know about these angles here? They're congruent. What are they called? Alternate interior angles. So we could put that marking there that these two are congruent. That is something we should recognize. That's going to help us a little bit later. Okay, questions? All right, let's flip this back over. Let's read number 1. A tree casts a shadow that is 21 meters long at a certain time of day. The angle of elevation, there's a key word there, the angle of elevation to the sun from the tip of the shadow is 51 degrees. What is the height of the tree? Okay, so here's our tree. Here's the ground. Here is the tree's shadow. Well, okay, I said it wrong. The shadow is down here. This is the sun ray coming down. So there's your sun. All right. Now, I want to make an emphasis on the shadow. And I have talked about this with you guys in the past. Your shadow, when you're dealing with this type of problem, is always on the ground. Your shadow is never hovering in the air. I say that because kids often mistakenly put the hypotenuse as the shadow. Will your hypotenuse ever be your shadow? No. Your hypotenuse is always going to be the ground piece here. Okay, a tree casts a shadow that is 21 meters long. So where does the 21 go? The ground, right here, from the tree to the tip of the shadow. The angle of elevation of the sun from the tip of the shadow is 51 degrees. So, from the tip of the ground to look up to the sun is 51 degrees. Where does the 51 go? Top corner or bottom corner? What did I say about angle of elevation? It's always going to be coming from the ground. So it goes right here. What was it? 51 degrees. Okay, angle of elevation. You're here. You look up. And it's, what was it? 51 degrees. Okay, to the sun from the tip of the shadow. Here's the tip of the shadow. So from the tip of the shadow up to the sun is 51 degrees. Does everybody see that? How tall is the tree? That's our X. What are we looking for? A length or an angle? A length, which means I can use Pythagorean's theorem, special right triangles, or SOHCAHTOA. Can I use Pythagorean's theorem? Do I have enough information for that? I don't have enough. I don't have another side. Could I use the 30, 60, 90, or the 45, 45, 90? No, I'm going to put a 90 in here. Could I use SOHCAHTOA? That's our last resort. That's the only thing we can use at this point. So you do what we've been doing. You take your pen or your pencil and you put a marking at the angle they give you, 51 degrees, and you label these two sides here because these two are the ones that have the numbers and the variable. 21, can you see that these two are adjacent because they touch the angle? If the two sides touch the angle, they're adjacent. But one's going to be the hypotenuse. Which one's the hypotenuse? The 21 or the unlabeled side? So I don't have to label it. If it's unlabeled, I'm not going to label it. What's the 21 then? Adjacent. Now, do you see that X goes across, and across is opposite, so X is opposite. Which one from SOHCAHTOA is opposite over adjacent? TOA. So we're going to be using tangent of an angle. Don't forget that. Tangent of what angle? 51 equals what over what? X over 21. We're going to have to solve this. Is this the easier one or the one with the extra step? Easy. How do we know it's the easier one? X is in the numerator. Okay, cross multiply. 21 times tan of 51 equals x. Ready to plug in, or do I have to divide? Plug it in. So you type in 21 times tangent of 51 equals, did you guys get 25.93284029? Yes? All right. When we're dealing with side lengths, we're going to round to the nearest tenths place. When we're dealing with angles, we'll go to the nearest whole number. So what is this to the nearest tenths place? 25.9 or 26? And I should have said that before I started to write it down. 25 point what? 9. 25.9, because the number past the 9 is not big enough to make the 9 bump up. Okay, did it give us units of measurement, meters? Questions on this, yes or no? Okay, next one. A helicopter is hovering over a landing pad 100 meters from where you are standing. Okay, so here's the helicopter. Okay, the helicopter is hovering 100 meters from, is hovering over a landing pad. So here's the hovering piece, and here is the landing pad. Can you guys, I'm not doing anything fancy there, they're just putting a dot, that's your landing pad. You're standing next to the landing pad or away from the landing pad? Read it. The landing pad 100 meters from where you are standing. So are you next to the landing pad or are you away from the landing pad? How far away? 100 meters. Okay, so the landing pad is 100 meters from where you are standing. The helicopter's angle of elevation with the ground is 12 degrees. What is the altitude of the helicopter? Okay, the helicopter's angle of elevation with the ground. Okay, now it says angle of elevation with the ground. So that means you are standing here. Now I know in the picture I showed you earlier, I said it's always going to be from your line of sight. That is still true, but from now on our line of sight will be from the ground, from the horizontal ground. So from the horizontal ground, looking up to the helicopter, what is the angle of elevation? 12 degrees. Okay, so angle of elevation for us will always be from the ground looking up. Ground looking up. So not from you standing here, finding your height, your eyesight, or your line of sight, and going from there. We're just going to assume it's from the ground. Okay, what is the altitude of the helicopter? What is altitude? Another word for altitude. Height. So where do I put my X? The ground, the hypotenuse, or the height? The height. Okay, which one is this? Pythagorean's theorem, special right triangles, or SOHCAHTOA? Is it SOHCAHTOA again? All right, put your pen or pencil marking at the angle they gave you. That's 12. They didn't give us the hypotenuse. I'm not going to label the hypotenuse. One of these is opposite, one of them is adjacent. You guys are paying attention. Opposite is across. Which one's across from the 12? The X or the 100? So this is opposite, and this one is what? Adjacent. And which one is opposite over adjacent? Tangent. Tangent of an angle, so tangent of 12, 100, or X? 12 equals what over what? X over 100. Easy problem or extra step problem? Easy. We cross multiply. When I cross multiply, can I multiply the 100 with the 12? No, I do 100 times tangent of 12, and I have to type it in like that, equals X. Ready to plug in, or do I have to divide? And do I have to use the inverse key on this one? No, because I'm not looking for an angle, I'm looking for a side, nearest tenths place. 100 times tangent of 12. Which part did I mess up on? Okay. 100 tangent of 12. Did you guys get it? 21.2 or 21.3? 21.3. And is it also in meters? Okay. Questions? Okay, next one. A person in a lighthouse 32 meters above sea level sights a buoy in the water. If the angle of depression to the buoy is 20 degrees, how far from the base of the lighthouse is the buoy? All right, so here's your lighthouse. Here's your water. And out at sea is your buoy. Or a ship. It can be whatever it needs to be. The person in the lighthouse is 32 meters. I'm going to make my right triangle first. Okay, the person in the lighthouse is 32 meters above sea level. Where does the 32 go? The ocean, the water, the hypotenuse, or the height of the lighthouse? Where does the 32 meters go? The water, the hypotenuse, or the height of the lighthouse? The lighthouse is 32 meters above sea level. Where? The hypotenuse?
Someone took a test in here yesterday after school, and she needs the test.
Yes. Give me a second. Okay, so where is it at? Where's the 32? The 32 is the lighthouse. A person in a lighthouse 32 meters above sea level. Do you see how that lighthouse is, the top of the lighthouse is 32 meters above sea level? Does that make sense? Yes? Okay. The angle of depression to the buoy is 20 degrees. What do we say about angle of depression? It's inside or outside the right triangle? Outside. Is it at the bottom by the ground or up at the top? Top. So here is where kids mess up. Kids will put the 20 degrees in here, and it's not. You do your angle of elevation, your line of sight, your horizontal line of sight, and your angle of depression is 20 degrees. Do you see how it is outside of our right triangle? Do you guys see that? So when you see problems that have, where does it say it at, angle of depression, know that it's going to be an extra step. You are going to have to draw your horizontal line of sight, which we did not have to do with the last two because the ground was our horizontal line of sight. We draw our horizontal line of sight, look downward to the buoy, and put our 20 degrees. Angle of depression will always be at the top outside. We talked about the Z shape earlier. Do you guys see the Z shape? Where can I put that 20? Can I put it down here at the bottom corner? Now do I have enough to find how far from the base of the lighthouse is the buoy? Where do I put my X? How far from the base of the lighthouse is the buoy? The base or the hypotenuse? Base. All right, I'm going to let you guys work. Figure out if it's SOH, TOA, if it's sine, cosine, or tangent. Label the 32 and label the X. One of them's opposite, one of them's adjacent. Please start to label. Sine, cosine, or tangent? Tangent. What is the 32 in reference to the 20? Opposite. What is the X in reference to the 20? So which one did you guys say it's going to be? Tangent of 32 over X? Yes? Easy one or extra step one? How can we tell there's an extra step? Because the X is in the denominator. Oh, thank you. Tangent of, did I say it and not write it, or did I not say it? Okay, said it, didn't write it. Thank you. Tangent of 20 is 32 over x. So x times tangent of 20 equals 32. What's the extra step here? Divide both sides, not by x and not by 32 and not even by 20. What do I divide by? Tangent of 20. Not just 20, but tangent of 20. You can't ever break up tangent with its angle unless using inverse functions. X equals, when you plug it in your calculator, you're going to use multiplication or division? Multiplication or division? Division. 32 divide tangent 20 degrees equals 87.9 or 88? 87.9, because the number after the 9 is not big enough to make the 9 bump up. 87.9. And does it give us units of measurement? Meters. Questions? All right, backside quickly. I'm going to jump to number 6 just in case we don't have time. And this one is a definite on your homework, and it is a little different than the others. At a certain time, a post, here's my post, that is 6 feet tall. Cast a 4-foot shadow. Where does the shadow length go? On the ground or on the hypotenuse? The ground. Here's your 4-foot shadow. What is the angle of elevation of the sun? So here's the right triangle. Remember, angle of elevation, here's your sun. Angle of elevation is always from the ground looking up to your sun. So where does my theta go? At the ground or up at the top of the post? Ground. Angle of elevation is always from the ground looking up. What is the angle of elevation to the sun? That should say to the sun. What is the angle of elevation to the sun? Theta is what I put it, and it's down the bottom right corner. And I usually use theta for angles. You don't have to, but I do. We're going to use SOHCAHTOA again. SOHCAHTOA. You start it the same way. Put your marking here. What is 6 in reference to theta? Opposite. Have most of these been tangents? Which they typically will be on these type of problems. What is the 4? Adjacent. So SOHCAHTOA, which one? Tangent of theta, tangent of 4, or tangent of 6? Always the angle. And equals what over what? Kids asked in my class yesterday, do we have to reduce that? You can. You don't have to, because the calculator is going to do it for you. What am I looking for here? An angle or a side? I'm looking for an angle. So what special key am I going to use? It's called the what key? Inverse. How do we write it down on our paper? Because you have to write it on your paper. Tangent, the -1, that's inverse tangent of 6/4, 6 divided by 4 equals theta. If you plug it in like that, it's going to reduce it and work it all out for you. Second tangent, 6 divided by 4 equals, and this is an angle, so we're going to round to the nearest whole number. We still have time, guys, so you're not packing up. What do we get? Theta equals 56 or 57? 56 what? No, not 0.3. We're going to leave a whole number, degrees. 56 degrees. Questions?